R6 is a pretty short section. It's just about synthetic division. Synthetic division is a neat trick to do long division quickly when the divisor is really simple. So let me look at this example. X minus 2 divided into x cubed minus 5x squared plus 4x minus 3. So let's see, what do I multiply this by to get that? It's x squared. I put an x squared up in the quotient. X squared times both of those would be x cubed minus 2x squared. Now I subtract that, and look, the x squareds cancel. This is minus 5x plus 2x, I beg your pardon, minus 5x squared plus 2x squared is minus 3x squared plus 4x minus 3. And I repeat the process. I'd have to multiply this x by negative 3 to get negative 3x squared. So I'll put a negative 3x up in the quotient. All right, so negative 3x times this gives me minus 3x squared plus 6x. Subtract it. The x squared terms cancel. This is 4x minus 6x is minus 2x minus 3. So what do I multiply this by to get that? The answer is negative 2. Put a negative 2 up in the quotient. And then multiply negative 2 times all of that. Now what's that called? Divisor. Negative 2x plus 4. Subtract. What's the remainder? Negative 7. Synthetic division is a trick based on recognizing that a lot of the stuff we wrote down here really isn't necessary. So here's how it goes. X minus 2. Put a 2 there. Put in that little box like that. Now in here, all these x's and cubes and stuff aren't necessary. If I just record the coefficients in the order in which they occur, I can convey the same information. So 1, negative 5, 4, negative 3. So the step is always you add 1 and there's nothing there, so 1. And then multiply. So this 1 times that 2 is 2. Add. Negative 5 and 2 is negative 3. Now multiply. 2 times the negative 3 I have here goes here. Right, so 2 times negative 3 is negative 6. Now add. Negative 2. 2 times negative 2 is negative 4. Add. Negative 7. I'll put a line there. You see what we got? That negative 7 is the remainder. And what do the 1, negative 3, 2 signify? Well, they're telling me the quotient. Right? This is telling me let's see, these are the coefficients of this polynomial that's the quotient written in descending order. So that's the constant term. This must be the x to the 1 term. That's the x squared term. So it's x squared minus 3x minus 2. Up here, this 1 stood for 1 times x cubed in the original polynomial, x cubed minus 5x squared, etc. So columns don't necessarily stand for powers of x anymore. But look how much shorter it all is. Can I use synthetic division for all long division problems? No. It only works when the divisor equals x minus some number c. If you're dividing by a quadratic, if you're dividing by a cubic, or if you're dividing by 2x minus some number, synthetic division doesn't apply. It only applies when you're dividing by 1 times x plus or minus some real number. And every real number can be thought of as, minus something. So even if I don't see a minus there, I can figure out what c is. For instance, if I were dividing, say, 3x cubed plus x minus 4 by x plus 3, I want this thing to equal x minus c. So I better use c equal negative 3. So I can do this synthetically like this. Put the negative 3 in that sort of half box. On this top line, I want the coefficients of this, this guy. So that's 3. But look, there's no x squared term. I have to include a 0 for the x squared coefficient, but then 1 and negative 4. But then the step is always add, multiply. Add, multiply. 28 times negative 3. 75 and 9 is 84, negative 84. When I add them, I get negative 88. That is, what that synthetic division just told me is that the quotient in this long division is 3x squared minus 9x plus 28, and the remainder is negative 88.